Okay, so let's turn that basic principle into a procedure. So this is our procedure for solving linear equations. Okay, we'll have to develop some new procedures when we talk about equations that are not linear. But in this chapter, just linear equations. So here's our procedure. First of all, if the equation has any fractions, you're going to start by clearing out the denominators, and the way you do that is multiplying both sides by the LCD of all the denominators in the whole equation, and I will do some examples for you of that. If you're lucky, your equation won't have any fractions, and so you just start with step 2, which is to remove parentheses using the distributive property. You're going to then add and subtract as necessary to get all x's on one side and all the constants on the other. And I didn't write it down because it's most people do this kind of automatically, but after you do that, combine all the like terms. Okay, and then last, you multiply or divide as necessary to finish isolating the x. Okay, so I'm going to emphasize that this step is last. And maybe I should remind us that our goal, when it says finish isolating the x, the goal is to have an equation that looks like x equals just a number. Okay, and that number is your solution. Okay, so x, in your final equation, x will be all by itself. It will be isolated on one side of the equation. And then last, check your solution by substituting it into the original equation. Okay, so here is an example using the procedure, and I'm going to start with an equation that doesn't have fractions in it. This one should be a review for you. The fraction ones are always harder, but we'll start without fractions. So solve minus 2 times the quantity x minus 3 equals 5x minus 9 plus x. So step 1 in our procedure is to clear out denominators of fractions, but we don't have fractions. Step 2 is to remove any parentheses using the distributive property. Okay, so I'm going to distribute that minus 2 into the parentheses. So minus 2x plus 6 equals. Now there's something else I personally would do here, even though it's not mentioned until step 3, I would go ahead and combine these like terms on the right hand side. 5x plus 6 is 6x. So maybe, so I'm thinking now perhaps the reason I didn't type in combine like terms here is that's something you want to do as you go along. Let's make a note of that. Where would be a good place to make a note of that? You can kind of decide for yourself where you would like to see that. I'm just going to stick it here. So from here on out, combine like terms as you go along. Okay, you don't have to wait for a specific step to do that, and it's good to do that as you go along because that keeps your problem more compact, simpler, easier to look at, and thus keeps you less likely to make mistakes. Okay, so I don't have to look at that 5x plus 6 now. It's combined as a 6x. That makes the problem a little easier. Okay, step 3 is to add and subtract until I get all the x's on one side and all the constants on the other side. So let's see, if I subtract 6x on both sides, I'll have all the x's on this side. Right, because 6x minus 6x is no more x's. Now, you might have preferred to add 2x to both sides. That's okay, it doesn't matter. And to get all the constants on the other side, I'm going to subtract 6. So minus 8x equals negative 15. And then your last step, don't do this until you've got a single x term equals a single number. Your last step is to divide out the coefficient on the x, that numerical factor in the x term. So we get x equals 15/8. Okay, your turn. Solve -3 times x minus 1 equals 4x minus 3 minus 2x. Please check your solution and then give me the solution set. I'll go over that with you in the next video. So see you then.